In this video, we're going to talk about suggested homework problems from 1.4. Let's go ahead and get started. The first question is question 3 here, and determine whether the limit as x approaches 3 of f of x exists and explain. They tell us that the limit as x approaches 3 from the left of f of x is 1, and the limit as x approaches 3 from the right of f of x is 1. So yes, the limit exists because the limit as x approaches 3 of f of x equals 1, since the limit from the left equals 1 and the limit from the right equals 1. So let's go ahead now and look at number 5 and use the graph to determine whether the limit exists and discuss the continuity of the function. So limit as we approach c, which is 4, c equals 4 here. For this first problem, limit as x approaches 4 from the right of f of x is equal to 3. Limit as x approaches 4 from the left of f of x is equal to 3. Limit as x approaches 4 of f of x is equal to 3, and f of x is continuous at x equals 3 because the limit as x approaches 4 of f of x equals f of 4. All right, let's go ahead and let's look at number 11. Find the limit if it exists, and if not, explain why. So as I approach 8 from the right, that's going to be 1 over 8 plus 8. It's 1 over 16. As I approach 5 from the right, limit as x approaches 5 from the right, minus 5 over x plus 5 times x minus 5. Limit as x approaches 5 from the right, 1 over x plus 5 is 1 over 5 plus 5 is 1 over 10. One and 1 is 2. So this is limit x approaches 1 from the left of x minus 1 times x minus 1 over x minus 1 is equal to 1 minus 1 is 0. Let's multiply this limit does not exist. Does not exist. We examine the graph of this function. Here we have asymptotes at 3 and negative 3 and 0. So we have horizontal asymptote at 1, and we're going to be above here. Let's just let my graphing calculator graph it for me. X over square root of x squared minus 9, zoom 6, like so. To show you it's getting close to 1, and it's getting close to negative 1 down here. Has two different horizontal asymptotes, 1 on the right and negative 1 on the left. But the limit as I get close to -3 doesn't exist because it's tending towards negative infinity. It is decreasing with that bound. Okay. We know what the absolute value of x over x looks like. We've talked about that one a few times. And as I get close to 0 from the left, only from the left here, then we are approaching -1. So that limit exists. Cosecant of pi x over 2 is 1 divided by sine of pi x divided by 2. And then as I approach 1, it's right there. It's in the domain, so 1, 1. So cosecant of pi over 2 is 1 over sine of pi over 2. Sine of pi over 2 is 1. 1 over 1 is 1. This is the greatest integer function right here. So that is 0 plus, sorry, that is -1/3. Just look on your number line here. Here's 0. Here's -1. Here's -1/3. The next lowest integer there is -1. Plus 3 is 2. All the way down to 43 now. This is a non-removable discontinuity at x equals 0. That's a vertical asymptote there. There are non-removable discontinuities at x equals -2 and at x equals 2, and those are both vertical asymptotes. There are no discontinuities here. This is the sum or difference of continuous functions. There are non-removable discontinuities at x is equal to -2 and x is equal to 2. Again, these are vertical asymptotes. Cosecant of 2x is going to have discontinuities at the zeros of sine 2x. So sine has zeros at 0, pi, 2 pi, and so on. So That's going to be um, odd multiples of pi over 2. No. Any multiple of pi over 2. So 0, 1, 2, yes. So let's solve it this way. Maybe you haven't seen it done this way in pre-calculus. So 2x is equal to 0 plus, and then every k pi, there's another 0. So I'm going to solve x is equal to k pi over 2. So these are going to be vertical asymptotes. So non-removable discontinuities at x equals the zeros of that. So these are vertical asymptotes. All right, that was 59. It's going down to 75 now. Continuity of a composite function. So h of x is equal to f of g of x, where f of x is equal to x squared, g of x is equal to x minus 1, h of x is equal to f of g of x is equal to some function squared. And that function, that inner function is x minus 1, which is x squared minus 2x plus 1. And that's continuous everywhere. It's a polynomial function. 96. The instructions here say use the intermediate value theorem to find the existence of a 0 in the interval. So f of x is equal to -5 over x plus tan pi x over 10. So f of 1 is -5 plus tan pi over 10. Let's go ahead and figure out what that is. -5 plus tan of pi over 10 is about -4.675. F of 4 is -5 over 4 plus tan of 2 pi over 5. -5 over 4 plus tan of 2 pi over 5 is 1.8277 approximately. Let's make sure that this function is continuous on that interval by looking at the graph here. So -5 over x plus tangent of pi x over 10, And I'm going to set my window here to be from 1 to 4. And smooth and continuous. The only problems here are going to be 0, which is not in my interval, or see, tangent of pi over 2. So when x is 5, which is not in my interval either. So we're good. And so because 0 is between negative 4.675 and 4.8277, and f of x is continuous on the interval 1 to 4 by the intermediate value theorem, at least 1, 0 exists in the interval 1 to 4. Okay. Number 99 is our last problem here using the intermediate value theorem. A graphing utility like our graphing calculator to approximate the 0 of the function on the interval 0 to 1. So they want us to repeatedly zoom in on the function to approximate it to 2 decimal places. There's actually a feature on the calculator we'll use to approximate it. So f of x is equal to x cubed plus x minus 1, f of 0. This is going to be continuous everywhere because it's a polynomial. So this is negative 1, f of 1, 1 plus 1 minus 1 is 1. 0 is between negative 1 and 1. So at least 1, 0 of f of x exists on the interval 0 to 1. And let's go ahead and graph it here. X cubed plus x minus 1, and window 0 to 1. It looks like there's only one x-intercept there, so second calc number 2, and we're on the left-hand side, on the negative side, and we're going to go to the right-hand side, to the positive side, and then we're going to come back and guess that it's right about there, and our 0 is approximately 0.68. It says to 4 decimal places here, 2, 3. That's what the calculator. Now they want us to find it to 2 decimal places just by zooming in. So with bisection, they called this. So we know that it's between 0 and 1. Let's go ahead and cut it in half and see if it's between 0 and 0.5 or 0.5 and 0. So we get 0 and 0.5. and 1. So it's in the interval of 0.5 to 1. And then we're going to bisect that some more and go 0.5 to 0.75. To 1. And we see that it's between 0.5 to 0.75. And then we're going to bisect it some more. And let's see here. So right now that's 0.25. So 0.125. So 0.5, 0.625, 0.75, like so. And so it's between 0.625 and 0.75. Then we can go a little smaller. Half of this is 0.0625. And once we get to here, we should be able to safely round soon. So let's go ahead and say this is from 0.625 to 0.625 plus 0.0625. It's that, and then just want to make sure that this plus this gives me what I think it does. Yes, it does. So I'm between 0.625 and 0.6875. I'm looking for the difference in the endpoints here to be where they would round to the same hundredth. So I'm not done yet. So difference now 0.03 125, 0.625 to 0.625 plus 0.03125, and then 0.6563 625 plus 0.03125 is there. So we are 0.6563 to 0.6875, getting real close now, because this is 0.66 and this is 0.68. Now my difference is 0.015625. Zero point 65625. This is not a 3, this is 25. 65625. There we go. And plus 0.015625 is that, and then left-hand side. So 0.671875, 0.6875, to 0.67, 0.69, so getting very close, 0.00788125. That's still negative, so it's going to be between this number here and this number here. And that rounds to 0.68, and that rounds to 0.69. So again, almost there. 0.00390625. So this is what is that's 0.6796875 plus 0.00390625 is a positive number. So that's my new right-hand side, 0.6796875 to 0.683599375, and this rounds to 0.68, and that rounds to 0.68, so this is approximately 0.68. Then I use the calculator to round it to 4 decimal places, and it's 0.6823. So that was it for this video. I know that last problem was kind of long. We'll come back next time and talk about section 1.5. See you for the next video.